Alright y'all, hi, hello, and welcome to homework video 14, where we are working with converting radians to degrees or converting degrees to radians. Reminder that our conversion factor here, if we're converting the following into radians, if we're going, oh, you can't see that, let's zoom in here. If we're converting from degrees to radians, what we're going to do is first, we're going to write it over 1, so 210 degrees over 1, times, we want degrees to cancel out, so if we have degrees in the top of the fraction, we want to multiply by degrees on the bottom. We're going to use 180 here because our conversion factor is in 180 degrees. There are pi number of radians. So if we're converting into radians, what we're doing is multiplying by pi over 180. Every single time we convert to radians. Okay? So when I multiply fractions, I now multiply straight across. So that's going to give me 210 pi over 180. You'll have to forgive my handwriting. I was just at soccer practice. It's very cold outside. My fingers are still frozen. Now that we have this fraction, we're going to reduce it down. We're going to keep pi as pi, and then we are going to reduce this fraction here. This fraction bar means division, so we're going to do 210 divided by 180. If I pop that in my calculator, I get 7 over 6. So my new fraction is 7 pi over 6 radians. Okay. And that is my answer here, converting from degrees to radians. Now here, I'm going the other direction. I'm converting radians into degrees. If I'm converting radians into degrees, I'm going to rewrite my fraction here of pi over 18 radians. Now what I'm trying to cancel out is radians. So if I'm trying to cancel out radians, those have to go on the bottom of the second fraction, and 180 goes in the top. So if we're converting to degrees, we're going to be multiplying by 180 over pi. Okay, so same fraction, just flipped. Again, when I multiply fractions, I multiply straight across. So this is going to be 180 pi over 18 pi. I've got pi on top and pi on the bottom, so the pi's cancel out. This fraction bar means division, so I do 180 over 18. That reduces down to 10, so I know that this is equal to 10 degrees. Okay. What you're going to do is take your conversions and fill in the rest of the unit circle here. So here I'm given 30 degrees. I'm going to write that as 30 over 1. If I'm starting in degrees, then what I need to multiply is by pi over 180 to get my answer here. If I start in radians, like this one over here, well, I've already found this one, but if I start with radians like this one over here, I'm going to multiply by 180 over pi. Okay, and write my answer here. So filling in the rest of your unit circle. We'll do one of the ACT problems together, and then we'll flip to the back. I'll zoom in a little here because I know that this is hard to read. This one says the diameter of the circle shown below is 18 centimeters. Okay, so across the entire thing is 18 centimeters. What is the circle's circumference in centimeters? So I'm looking for circumference, so I'm going to be using this formula here, which is circumference equals 2 pi r. Now the tricky thing about this question is it gives you a diameter, but the formula needs to use radius. Okay, so what I do diameter, we need half of that, right? We want a radius that goes from the center of the circle to the outside of the circle. So I do 18 divided by 2 gives me 9 as my radius. Okay. From there, I just plug it in. I now have circumference is equal to 2 pi times a radius of 9. I can combine my like terms together here. Circumference is 2 times 9 is 18, and I've still got the pi. Correct answer here is B. Okay, that is it for the front of the homework, or at least it for the ones that I'm going to help you on. I'll leave you to the rest of the fun of the front of homework 14. On the back of homework 14, I'm going to zoom out a little bit here. I'm going to give you some hints on on both of these problems, but I'm not going to fully solve any of them for you. Okay, so on this one, it says the following diagram shows a circle with a center O and radius R in millimeters. The circle is divided into 5 equal sectors. This is really, really important. 5 equal sectors. The area of sector AOB is 20 pi millimeters squared. Before we really get started here, I should write down 2 formulas for you. Area of a sector is 1/2 theta r squared. And then arc length is theta times r. Okay? Reminder that both of these must be in radians. For theta to work, it has to be in radians. Okay? So, and then it gives us the entire area of this sector. These are 2 really important pieces of information. So the first thing it says is write down the exact value of theta in radians. Okay? The only thing I have to work off of is that I know that it's in 5 equal sectors. So I know that this one is the same as this one, is the same as this one, is the same as this one, is the same as this one. Okay? Well, I know they're all the same degree measure. The way that I did it is I know that there are 360 degrees in an entire circle. Okay, so 360 degrees is equal to an entire circle. I'm going to divide that by 5 because I have 5 equal sectors. So if I do 360 divided by 5, when I plug that in my calculator, I get 72 degrees. Now that I then need to convert to radians, but I'll let you set up your conversion factor here. Check the front of your homework if you can't remember how to do that, so we can convert it into radians. Okay? Next, it tells me to find the value of r. So I need to find the value of my radius. Okay? Well, I guess I kind of need this one to help you out here. Once you multiply this out, you should find out that theta is equal to, we'll have, for our conversion ratio here, I've got degrees on top, need to cancel out degrees on the bottom, pi on the top, 72 pi over 180, reduce that down, 72 divided by 180, I get 2 over 5. So I know that theta is equal to 2 pi over 5. That's what I did when I converted it into radians. I don't know what r is equal to, okay? But I do know that the entire area of the circle is 20 pi millimeters squared. I do know that the entire area is 20 pi, okay? That is enough information for me to plug into my area of a sector formula up here. So I'm going to plug in what I know. I know A is equal to 20 pi. So 20 pi is equal to 1/2 theta, which is the angle you found here. So 1/2 times 2 pi over 5. All of that times the radius squared. Okay. From there, you're going to try to get r by itself. From there, you're going to get r by itself. Okay, last one it says is to find AB. Okay, well, AB is this distance right here. Okay, this distance right here. When you solve this down, you should get r is equal to 10. So that's the way that you can check your answers here. You should get r is equal to 10 when you do the work here. Now make sure you do the work, because on your homework quiz, if I just see this and this, I won't give you full credit. Actually do the work to solve for r. Okay, so now I'm going to find AB. What I did was I redrew this triangle here. Okay, so I'm going to take this triangle that I've outlined in red, and I'm going to redraw it down here. I know that this is A, this is B, and this is my angle measure. Okay, well, there are some things that I found out about this triangle. I know that this is 72 degrees. I found that out in part 1. I know that the radius is 10. So if the radius is equal to 10, this side of the triangle is equal to 10, and this side of the triangle is equal to 10. Okay, both sides of the triangle are equal to 10. What that means is, remember way back in our isosceles triangle rules, if this side is equal to this side, means this angle is equal to this angle. So you can figure out these two angle measures by doing 180 minus 72. So an entire triangle is 180. We're going to subtract out 72. So 180 minus 72 is 108. Now 108 is for both of these angles, but these angles have an equal measure, so I can do 108 divided by 2. 108 divided by 2 gives me 54. So I know that each angle here is 54 degrees. Now what I'm trying to find is the value of AB, or this side here. When I'm looking at this, I see that I know the value of an angle and its opposite side. So I can use sine rule here to solve. So an angle and its opposite side, I can use sine rule here to solve. That would give me sine of 54 over 10 equals sine of 72 over its opposite side of x. From there, you can solve for x. Okay, pretty much walked you through that one. You've got a little work to do on your own. On this one, I'm going to give you two teeny tiny hints before you have to do it yourself. Express the angle measure in degrees. Check the front for converting from degrees to radians. Okay, for find the length of the arc, you should be able to use your formula for that. Find the area of the shaded region. Be really careful about this one here. Shaded region is this entire space up here. Okay, you're looking for the area of this shaded region. The way that I thought about it was the area of the entire circle minus the area of the sector. That should help you find the entire shaded area. Okay, last one we shall do together is this bottom ACT problem. It says the circumference of a circle is 50 centimeters. So if I draw a circle, the circumference, or the distance around, is equal to 50 centimeters. What is the length in centimeters of the diameter of the circle? So I'm trying to find this distance here. That's what I want to know. Okay, well, I know the circumference. Wherever I see circumference, I can plug in 50. So that's going to give me 50 is equal to 2 pi times the radius. So I'm trying to get r by itself. That's what I'm trying to solve for. Because from the radius, I can figure out what the diameter is. So what I did, I divided by 2 on both sides first. So that gave me 25 is equal to pi r. And then I divided by pi on both sides. So that gives me that my radius is equal to 25 over pi. Well, it didn't ask for my radius, it asked for my diameter, right? Radius is only half of this. So to get to my diameter, I would take my radius and multiply it by 2. 25, I'm going to write it as 2 over 1, so it now looks like two separate fractions. When we multiply fractions, we multiply across. 25 times 2 gives me 50. 1 times pi gives me 1 pi. So my diameter here, which is twice my radius, is 50 over pi. Okay, that is it for the homework video. I apologize for my bad handwriting. My fingers are just now not numb from soccer practice, though in all honesty, my handwriting is usually this bad. Thanks for tuning in. It's been a blast. See you next time.